Close your eyes for a moment, or don't. Just let them soften. Outside, it's raining. Not a storm, not thunder, just steady rain. The kind that settles in quietly and doesn't ask for attention. And within seconds, something shifts inside you. Your shoulders drop, your breathing slows, your thoughts lose their sharp edges. It's strange, isn't it? Water is falling from the sky. That's all it is. Physics, gravity, droplets meeting glass. And yet your nervous system reacts as if someone has whispered, softly, that you are safe. Why? Why does rain, of all sounds, seem to reach directly into the brain and gently turn the volume down? Tonight, we're going to explore that, slowly, not in a bright, clinical way, but the way you talk about something beautiful at the end of a long day. So let yourself settle in, and let's talk about what rain is really doing to your brain. The first question: why does rain feel different? It begins with a moment most of us have had but never quite interrogated. You're inside somewhere, a car, a bedroom, a library, and it starts to rain. Not a drizzle, not a downpour, but that middle kind of rain. That earnest, purposeful rain that arrives as though it means business. And something in you, something entirely involuntary, exhales. Your shoulders drop a fraction of an inch. Your jaw unclenches. The running commentary in your head. The to-do lists, the replayed conversations, the vague anxieties, all of it gets quieter, not because you willed it to, but because something underneath your conscious mind made a decision for you. That decision, it turns out, is thousands of years old. To understand why rain sounds feel different from other sounds, you need to understand something fundamental about the way the human brain processes the world around it. And that starts with one of the most important jobs the brain has ever had: threat detection. The human brain is, at its core, a prediction machine. It is constantly, ceaselessly, building models of what might happen next. Is this situation safe? Is that sound a threat? Should my body be preparing to act? Or is it allowed to rest? This is not a metaphor. This is literally what enormous portions of your brain are doing at every waking moment, and for significant stretches of your sleeping moments too. The amygdala, a small almond-shaped region buried deep in your temporal lobe, is the chief architect of this surveillance operation. It monitors incoming sensory information, what you see, what you hear, what you smell, and makes lightning-fast decisions about how much danger is present. The amygdala is old. Not old in the sense of aging, old in the evolutionary sense. It predates most of the sophisticated circuitry that makes human beings human beings. It was doing its job long before language, long before abstract thought, long before you were capable of worrying about whether your email came across the right way. It is ancient and it is good at its job, and the way it does its job matters enormously for why rain sounds the way it does to your nervous system. Now, what the amygdala is particularly sensitive to are sudden, unpredictable sounds. Loud, sharp, unexpected noises. A snap, a crack, a voice raised without warning. These are the sounds that, over hundreds of thousands of years of human evolution, were most likely to signal danger. A predator moving through undergrowth, a piece of territory being contested, an alarm call from another animal. The brain learned, not in your lifetime, but in the slow, accretive way that evolution teaches things, to treat sudden sounds as potential threats until proven otherwise. That's the system that gets activated when a car backfires or someone drops a tray in a restaurant. Your heart spikes, your muscles tighten, your attention narrows to a point. That's your amygdala doing exactly what it was built to do, even when the actual threat is exactly zero. Now think about rain. Rain doesn't snap. Rain doesn't crack. Rain doesn't rise unpredictably in pitch or rhythm. Rain does not, in any configuration that soft rain typically takes, signal danger. It is, in the language of the nervous system, a non-threatening sound. Not just neutral, actively, categorically non-threatening. It is predictable. It is continuous. It lacks the acoustic properties that the threat detection system is listening for. And here is where it gets interesting. When the amygdala determines that a sound is non-threatening, it doesn't just do nothing. It actually down-regulates the entire threat detection system. It lets go. The body gets a signal you can ease up. The parasympathetic nervous system, the branch of your autonomic nervous system responsible for rest and repair, the counterpart to the fight-or-flight response, gets a little more room to operate. All of this happens without your involvement. You don't decide to relax when it rains. Your brain decides for you, based on a calculation that was programmed into your nervous system over a time frame so vast it's almost impossible to conceive of. But there's more to it than just an absence of threat. Rain doesn't just pass the threat detection test. It actively provides information that tells the brain the coast is clear. To understand why, we need to think about what the world would have sounded like to our ancestors. Not just to Homo sapiens, but to the hominids who came before, creatures living in open grasslands and forests in Africa, then gradually spreading across the planet over the course of 1 million years or more. In those environments, the ambient soundscape was information-dense and vital. Bird calls indicated the presence of certain animals or conditions. Sudden silences from insects or frogs could mean a predator was nearby. The sound of water flowing was often a sign of a resource, a safe drinking spot, or a landmark. Animal vocalizations communicated territorial boundaries, mating opportunities, danger. And rain filled everything in. Rain was what acoustic ecologists now call a masking event. A broad, continuous sound that covered the soundscape like a blanket. During rain, predators couldn't move as quietly. Small prey animals often sheltered in place. The world, in a sense, paused. You could not hear as much during rain, but neither could anything that might be hunting you. For our ancestors, a steady rain was often a sensory permission slip. The hunting conditions for most large predators become significantly less favorable in heavy rain. The sound masking effect works both ways, but a group of hominids sheltering under trees or a rock overhang during rain was in a comparatively safe position. They could rest. They could be still. They could let their guard down just a little in a way that the relentless demands of open environment survival rarely allowed. Over hundreds of thousands of years, the nervous systems of our ancestors learned to associate the sound of continuous rain with a period of permissible rest, with shelter already found, with the temporary suspension of the need for maximum vigilance. That association didn't disappear when we built houses. It didn't vanish when we invented central heating or double-glazed windows. It is still in there, in the oldest parts of your nervous system, humming away in the background. When you hear rain, part of your brain recognizes the signal that has been meaningful to your lineage for an extraordinarily long time. The rain is here, you found shelter, you can rest. And so you do, without thinking about it. without choosing it. You just do. There is something quite moving about that when you let yourself sit with it. The rain falling outside your window right now, or the rain sounds playing through your headphones, is speaking a language that predates English, predates writing, predates civilization. It is saying something so simple that it doesn't need words. You are safe. You are inside. This is a rest time. Your brain is listening. Now, this is the beginning of the story. The evolutionary explanation is real and important and well supported by the science of threat detection and the autonomic nervous system. But it's only the first layer. Because rain doesn't just say, you're not in danger. Rain, it turns out, does something extraordinarily active inside your brain. It changes the way your neural oscillations behave. It alters your brain's chemistry. It reaches into your memory systems in ways that are both beautiful and scientifically verifiable. And it does something remarkable in the part of your brain that processes sound itself. So let's go deeper. Pink noise and the architecture of sound. Before we go any further into the neuroscience, let's spend some time with the actual sound of rain. Because rain, acoustically speaking, is a very particular and unusual thing. And understanding what it is at the level of pure sound science helps explain what it does to your brain. You have probably heard the term white noise before. White noise gets recommended for sleep, for focus, for drowning out distractions. You might have a white noise machine or an app that plays white noise. And if you've used it, you know that it works, at least to some degree. But you might also have noticed that it can feel slightly harsh, slightly metallic, like the sound of television static or a detuned radio. There's an edge to it. That edge is not accidental. White noise is defined very specifically. It is sound that contains all audible frequencies, from the very lowest that the human ear can detect to the very highest, at exactly equal intensity. Every frequency from around 20 Hertz all the way up to about 20,000 Hertz is present in equal measure. It is the acoustic equivalent of white light, a complete spectrum uniformly distributed. The problem is that the human ear doesn't hear all frequencies equally. Our ears are more sensitive to higher frequencies. So a sound that contains equal energy at all frequencies will be perceived as having a lot of treble, a lot of hiss. That's why white noise can feel sharp or irritating for some people. It is technically complete, but it doesn't feel balanced. Pink noise is different. Pink noise, and this is where rain enters the conversation, contains all audible frequencies, but the energy is not uniformly distributed. Instead, the energy decreases as the frequency increases. Lower frequencies have more energy. Higher frequencies have less. This creates a particular relationship between frequency and power. Scientists call it a 1/F relationship, meaning the power is inversely proportional to the frequency. And the result is a sound that, to the human ear, feels balanced, full, and smooth. Rain is pink noise. Or more precisely, rain is very close to pink noise. When you measure the acoustic properties of steady rainfall, you find this same characteristic. A broad spectrum of frequencies with more energy concentrated in the lower ranges, tapering off as you move higher. The sound is not a single frequency, like a musical note. It is not a handful of frequencies like a chord. It is a continuous wash of sound that covers the entire audible spectrum and more, weighted toward the lower, warmer end. This matters enormously for the brain, and here is why. Your brain is itself a system of oscillations. Your neurons fire in patterns, and those patterns have rhythms, and those rhythms are what we call brainwaves. You've probably heard of some of them. Alpha waves, which oscillate at around 8 to 12 cycles per second, and which are associated with relaxed, calm wakefulness, the state you're in when you've closed your eyes but aren't yet asleep, when your mind is wandering pleasantly rather than focusing hard. Theta waves, which run at 4 to 8 cycles per second and appear during light sleep and deep meditation. Delta waves, the slow, rolling waves of 0.5 to 4 cycles per second that characterize deep, dreamless sleep. And here is something remarkable. The power distribution of these brainwaves follows a pattern very similar to pink noise. Lower frequency brainwaves, delta waves, have more power than higher frequency brainwaves, which decreases as you go up the spectrum. Your brain, in a sense, naturally operates in a pink noise pattern, and research suggests that sounds matching this pattern, sounds that mirror the natural rhythm of the brain's own oscillations, are particularly stabilizing for neural activity. Studies on pink noise and sleep have found that steady pink noise can reduce the complexity and variability of brainwave activity during sleep, leading to more stable, more restorative sleep stages. A study published in the Journal of Theoretical Biology found evidence that pink noise improved memory consolidation during sleep. Another small but significant study found that older adults who slept with pink noise playing showed improved performance on memory tests the following morning. The researchers believed this was because the pink noise was helping to synchronize and stabilize slow oscillations during deep sleep. The very oscillations that are critical for consolidating memories from short-term to long-term storage. Rain also provides what researchers and sleep therapists call acoustic masking. This is the effect you're probably most consciously aware of when you put on rain sounds. It drowns out other noises. The dog barking, the car alarm, the conversation from the apartment above. The sporadic, unpredictable sounds that would otherwise jab at your brain's threat detection system and pull you back from the edge of sleep. The masking works because rain, being a broad-spectrum sound, overlaps with and fills in the frequency range of most disruptive ambient noises. When the rain is playing, those sudden sounds are still there. They still happen, but they emerge from the constant rain background rather than emerging from silence. And a sound emerging from a continuous background is far less jarring to the nervous system than a sound that erupts into silence. The contrast is reduced. The acoustic surprise is muted. The amygdala gets a gentler signal or sometimes no significant signal at all. There is also a quality to rain sounds that goes beyond simple masking. Researchers who study acoustic environments for well-being have noted that rain is what's called a temporally complex but locally predictable sound. What that means is, the overall pattern of rain is steady and continuous, locally predictable. You know the next second will also sound like rain. But the exact pattern of individual drops is varied and non-repeating, temporally complex. It isn't a loop. This is different from a simple tone, which is too monotonous and can actually become irritating. And it is different from speech or music, which is complex in ways that engage the language and meaning processing centers of the brain, keeping those systems active when you want them to go quiet. Rain lands in a middle space that is, neurologically speaking, very useful. Complex enough that the brain is mildly engaged, kept company as it were, but predictable enough that it never demands active analysis. The brain receives the sound, processes it as non-threatening and non-urgent, and then essentially parks it in the background as environmental ambience. This frees up the higher cognitive systems, the prefrontal cortex, the language centers, the problem-solving networks to gradually disengage, to let go, to begin the downregulation that precedes sleep. And there's one more acoustic property worth mentioning. Rain sounds tend to fall in the range of 0 to 20 kilohertz, covering the full audible spectrum, but with a particularly soothing quality in the lower range, roughly between 100 and 1000 hertz, that corresponds to sounds that many humans find inherently calming. This frequency range overlaps with the human voice in its lower, softer registers, with the sound of a heartbeat, with the low frequencies of many of the most comforting sounds humans experience in early life. The sounds heard in the womb, filtered through amniotic fluid, which emphasized lower frequencies over higher ones. There is a speculative but intriguing theory that rain's frequency profile resonates with something very deep in human memory, pre-memory, perhaps the acoustic experience of the earliest weeks and months of existence, before consciousness, before language, in a warm, enclosed space where everything was continuous sound and safety. The research on this specific theory is limited, and we should be careful not to overclaim. But it is worth noting, the frequency profile of rain is not arbitrary. It overlaps with sounds that the human nervous system has, across different stages of life, consistently associated with safety and closeness. The sound of rain is not random noise. It is, in ways both acoustic and neurological, a near-perfect match for what the brain needs to let go. The ancient brain, an evolutionary story. Let's go back in time, a long way back. Somewhere around 2 million years ago, a species of hominid was learning, for the first time, to navigate open savanna environments in what is now sub-Saharan Africa. These were not quite Homo sapiens, they were predecessors, perhaps Homo habilis or early Homo erectus, but they were recognizably in our lineage. They had brains that were larger than their ape ancestors, and they were learning to use stone tools. They lived in groups. They communicated. They were, in the grand scale of things, staggeringly vulnerable. The savanna is a difficult place to live if you are not built for it. Lions, leopards, hyenas, wild dogs. An array of predators that were faster, stronger, and often better adapted to low-light hunting than these early hominids were. The primary defense against these threats was not speed. It was not strength. It was awareness, vigilance, an extraordinarily sensitive threat detection system that was constantly monitoring the environment, constantly asking, is something out there? Is something moving? Is that sound normal? This is the context in which human auditory processing evolved. Not in the quiet safety of a bedroom, in an environment where correctly interpreting a sound, that rustle, that distant call, that sudden silence, could mean the difference between surviving and not. The threat-activated vigilance system, as researchers have come to call it, is the brain's primary response to unexpected sounds. When a sudden, novel sound is detected, the auditory cortex flags it, the amygdala assesses the emotional significance, and within fractions of a second, a cascade of physiological responses is initiated. Heart rate increases, cortisol is released, muscles prepare for action, attention narrows and sharpens. This is not under your voluntary control. This system operates faster than conscious thought. By the time you are aware of having heard something startling, your body has already begun preparing for whatever comes next. The key word is unexpected. The threat-activated vigilance system is exquisitely sensitive to sounds that break pattern. Sounds that emerge from silence or that change suddenly in pitch or volume. Sounds that don't fit the expected background. A twig snapping in a quiet forest. A voice suddenly raised. an engine cutting out unexpectedly. These sounds carry a flag that the brain interprets as, "Pay attention. Something changed. Be ready." Now consider what this means for your sleep. When you try to sleep in a modern environment, an apartment, a house in a city or suburb, the soundscape around you is full of exactly these pattern-breaking sounds. Car accelerating, a door slamming, someone's television through the wall, a phone notification from another room. Each of these sounds is individually minor, harmless. You know this consciously, but your threat-activated vigilance system does not care what you know consciously. It responds to the acoustic signature of each sound, and many of them carry the signature of novelty, of unexpected change, of pattern disruption. This is why so many people find it difficult to sleep in noisy environments. Not because the sounds are actually dangerous, but because they keep triggering a system that is still operating as though the sounds might be dangerous. Rain, as we have established, bypasses this system almost entirely. But there is something additional happening, beyond simply not triggering the threat response. Rain actively suppresses it. This is the acoustic masking effect we touched on earlier, but let's go deeper into the mechanism. When rain is playing really steady, continuous rain, it creates a consistent acoustic floor. Ambient noise that was previously emerging from silence now emerges from rain background. And what happens to the novelty of those intrusive sounds when they emerge from a rain background rather than from silence? It diminishes. A car horn that would normally spike out of quiet like an alarm becomes a car horn slightly above the level of the rain. The contrast is less. The acoustic signature of sudden, novel danger, the thing the amygdala is listening for, is softened, muted. The amygdala receives a less urgent signal, or in some cases, no significant signal at all. This is not just theoretical. Research from Brighton and Sussex Medical School, published in 2017 in the journal Scientific Reports, used brain imaging and heart rate monitoring to study what happens in the body when people listen to natural sounds versus artificial sounds. The researchers, led by Dr. Cassandra Gould Van Praag and colleagues, found that natural sounds, including rain, produced measurable changes in the autonomic nervous system. Specifically, they found that natural sounds shifted the balance of activity away from the sympathetic nervous system, the fight or flight branch, and toward the parasympathetic nervous system, the rest and digest branch. The brain, while listening to nature sounds, showed changes in the resting activity of key networks, including the default mode network, which we will get to shortly, that were consistent with a state of relaxed, inward-facing attention. In other words, listening to rain didn't just mask other sounds. It actively changed the functional state of the brain. It nudged the nervous system toward rest. And there is another layer to this, one that gets into something more speculative but scientifically plausible. Remember those early hominids on the savanna? During rain, heavy enough that staying out was uncomfortable but light enough to shelter from, what would the acoustic world have been like? Other animals seeking shelter. The savanna falling quiet, birds hunkering down. Even the large predators, the lions, the leopards, were less likely to be moving and hunting in heavy rain. Their prey could smell better in rain. Their paw prints were visible in wet ground. Their approach was louder. For a group of hominids huddled under a rocky overhang or in a thicket, heavy rain was one of the few times the ambient threat level genuinely dropped. Rain sounds in this reading are not just neurologically safe. They are evolutionarily coded as a signal that a particular kind of rest time has arrived. The kind of rest time that was rare and precious in the lives of our ancestors. The kind of rest time you could actually lean into because the world had briefly become less dangerous. That ancient code is still running in your nervous system. Every time it rains, a signal goes out that predates civilization, predates agriculture, predates fire. And your body responds to it the same way your ancestors did, by letting go just a little of the constant work of being alive and alert. There is something in that worth sitting with, something humbling and wonderful, both at once. You are not just a modern person listening to rain sounds on a sleep app. You are a link in an unbroken chain of humans who have been soothed by this exact sound. The continuous, non-threatening, pattern-filling sound of water falling from the sky, all the way back to the beginning of what it meant to be human. Now, that evolutionary story is compelling. But what is happening in the present-day brain, in the actual neurons and chemicals, when rain starts to fall? What changes and why and in which direction? That's where we're going next. The parasympathetic nervous system, your body's off switch. Your body has two main gears. One is what most people know as fight or flight. The scientific name is the sympathetic nervous system, and its job is to prepare you for action. When it's activated, your heart beats faster, pumping more blood to your muscles. Your breathing quickens and shallows, bringing more oxygen. Your pupils dilate to take in more visual information. Your digestive system slows down because digestion is not a priority when you might need to run. Your liver releases glucose into the bloodstream for immediate energy. Your adrenal glands release adrenaline and cortisol being the longer-acting stress hormone that sustains the state of alertness and readiness. This system is not bad. It has kept your lineage alive through an extraordinary amount of difficulty. When you need it, there is nothing more useful in the world. But the sympathetic nervous system is not supposed to be constantly on. It is designed for acute situations, bursts of activation, followed by return to baseline. The problem is that in the modern world, it often does not return to baseline. It stays elevated. It runs at a low to moderate level of activation almost continuously, not because we are facing constant acute physical threats, but because our nervous systems cannot fully distinguish between the physiological signature of a lion approaching and the physiological signature of a looming work deadline or an argument with someone we love or a news feed full of catastrophe. Chronic low-level sympathetic activation, chronic stress, as we call it, is associated with a long list of health consequences. Elevated blood pressure, impaired immune function, difficulty sleeping, digestive problems, heightened anxiety. Over time, chronically high cortisol is associated with reduced volume of the hippocampus, the brain region critical for memory formation and emotional regulation. Now, the other gear. The parasympathetic nervous system is sometimes called rest and digest, and this captures it well. When the parasympathetic system is dominant, heart rate slows and becomes more variable and adaptable, a measure called heart rate variability, which is associated with health and resilience. Breathing deepens and slows. The digestive system resumes its work. Blood pressure lowers. Cortisol levels drop. The muscles soften. The jaw unclenches. The eyes, which had been slightly too wide, relax behind closed lids. This is the state of genuine rest. This is the state that precedes sleep. This is the state in which your body does its repair work, Immune cells patrol, cellular damage is addressed, memories are consolidated, hormones are regulated. The parasympathetic nervous system is controlled partly by the vagus nerve, one of the longest nerves in the body, running from the brainstem all the way down through the neck, chest, and abdomen. The vagus nerve is sometimes called the wandering nerve. Vagus is Latin for wandering, and it interfaces with the heart, the lungs, the digestive tract, and many other organs. Stimulating the vagus nerve in various ways promotes parasympathetic activation and the state of deep rest. And here is where rain comes back in. Multiple studies have now shown that listening to natural sounds, specifically the kind of predictable, continuous natural sounds that rain exemplifies, produces measurable increases in parasympathetic activity and measurable decreases in sympathetic activity. The Brighton and Sussex Medical School study I mentioned earlier found exactly this. fMRI imaging showed changes in the default mode network of the brain consistent with inward, restful attention, and heart rate monitoring showed autonomic nervous system shifts toward parasympathetic dominance. Other research has found that rain sounds and water sounds more broadly reduce levels of cortisol, the stress hormone, in measurable ways. A study published in PLOS One found that participants who listened to the sound of rippling water before and during a stress test showed the lowest cortisol levels among the different conditions tested. The water sound group also showed the fastest recovery of the other stress biomarkers measured. The researchers concluded that natural water sounds may have a uniquely powerful effect on stress physiology, above and beyond other calming stimuli. Additional research has confirmed that rain sounds reduce blood pressure, slow heart rate, and increase heart rate variability, all markers of increased parasympathetic tone. These are not subtle effects happening at the margins. They are measurable, replicable physiological changes, occurring in response to a sound that we have been treating, for most of human history, as simply weather. What is happening mechanically? How does a sound get from your ears into your nervous system in a way that changes your heart rate and cortisol levels? The pathway goes something like this. Sound waves enter your ears and are converted by the mechanical action of the eardrum and the tiny bones of the middle ear into nerve signals. These signals travel along the auditory nerve to the brainstem's auditory nuclei, and from there to the auditory cortex, where the sound is processed and interpreted. But the auditory cortex doesn't operate in isolation. It is deeply connected to the limbic system, including the amygdala and hippocampus, and to the hypothalamus, the master regulator of the autonomic nervous system. When the amygdala receives a sound it evaluates as non-threatening, like rain, it does not send an activation signal to the hypothalamus. Instead, the hypothalamus can shift its output toward parasympathetic rather than sympathetic activation. This sends a message through the vagus nerve and other parasympathetic pathways, which in turn reduces adrenaline and cortisol output from the adrenal glands, slows the heart, and produces all the physiological markers of rest. The sound goes in your ears. The brain evaluates it. The nervous system shifts. Your heart slows. Your breathing deepens. The cortisol drops. You feel genuinely calmer. And this process is not a placebo. It does not require you to believe in it or to be trying to relax or to be aware of it at all. Studies have shown these physiological effects even in people who are not consciously focused on the rain sounds, people who have them playing in the background while doing something else. The nervous system is listening and responding independently of your conscious awareness. There's also an interesting interaction with melatonin, the hormone that regulates your sleep-wake cycle. Rain tends to darken the sky, reducing light levels, and lower light levels suppress the inhibition of melatonin production by the eyes. But beyond the light effect, the reduction in cortisol that rain sounds produce may also facilitate melatonin synthesis, since high cortisol and melatonin work against each other in the body's nocturnal chemistry. When cortisol drops, the conditions for melatonin production become more favorable. When melatonin rises, the signal to the brain and body that sleep time is approaching becomes stronger. Rain, in other words, does not just mask disruptive sounds. It does not just fail to trigger your alarm system. It actively alters your body chemistry in the direction of rest, repair, and sleep. It changes your hormones. It changes your heart rate. It changes the way your brain's networks are communicating with each other. The next time you feel your body soften in the rain, know that what you are feeling is real. It has a mechanism. It has a name. And the name, if we were to give the whole cascade one name, would be something like coming home to rest. Let's keep going deeper. The default mode network and the wandering mind. Your brain has two broad modes of operation. Not literally two. The brain is vastly more complex than a simple binary. But two tendencies that neuroscientists have given names to because they appear so consistently across all people in brain imaging data gathered over decades. The first is sometimes called the task-positive network. This is the constellation of brain regions that become active when you are focused on something external. Solving a problem, reading a text and extracting meaning, driving, responding to someone in conversation. The task-positive network is goal-directed, outward-facing, engaged with the world. The second is the default mode network, or DMN. This is the constellation of brain regions, including the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus, among others, that become active when you are not engaged in a specific external task. When you are daydreaming, when your mind is wandering, when you are reminiscing or imagining the future, or simply resting without focus. For a long time, the default mode network was treated as a kind of placeholder, the brain's idle state, what it did when nothing important was happening. But more recent research has revealed that the default mode network is anything but idle. It is actively involved in some of the most important things the brain does. Integrating past experiences into a sense of self, simulating possible futures, making meaning out of what has happened to us, consolidating memories, regulating emotion. The DMN is also deeply involved in the process of falling asleep. As you drift from wakefulness towards sleep, the DMN tends to become more active. The mind turns inward, thought becomes less tightly organized, memories and images begin to drift and associate freely. This is the hypnagogic state, the liminal zone between waking and sleep, and it is in many ways mediated by the increasing dominance of the default mode network. Now, here is where rain sounds intersect with this beautifully. The Brighton and Sussex Medical School study we've discussed several times found something very specific about what happens to brain activity when people listen to natural sounds like rain. The brain's default mode network shifted in a particular way. The researchers found that, while listening to natural sounds, the default mode network shifted toward more outward-focused patterns, the kind of gentle, relaxed attention that is associated with rest without rumination. Not the tight, anxious inward focus of worry or self-criticism, which also activates the DMN in a different and less helpful pattern. Instead, the particular kind of resting, wandering, pleasant inward attention that the DMN produces during its best moments. What this means practically is that rain sounds promote a state of mind that is neither vigilantly outward-focused, which keeps you awake, nor anxiously self-focused, which also keeps you awake, often in distressing ways. Instead, it promotes a gently drifting quality of attention, the mind moving softly from thought to thought, image to image without urgency. This is the phenomenological signature of the state just before sleep. It is the state many people are seeking when they say they want to turn their brain off. They don't actually want to turn it off. They want to shift it into this mode. The mode of gentle, undirected, meandering attention, where the stories and sounds and images come and go without demands being made of them. Rain facilitates this shift, not by turning the brain off, but by providing exactly the right acoustic backdrop for the default mode network to do its best, most restful work. A backdrop that says, nothing needs solving right now. Nothing needs attending to with urgency. You can let the mind wander. You can follow the threads of thought wherever they go, slowly, without them needing to lead anywhere. And there's something else connected to this, something that has to do with mind wandering specifically, and why it matters for sleep. Research on the default mode network has found that mind wandering is not the same as distraction. Genuine mind wandering, the kind that happens in a safe, relaxed state, is constructive. It is associated with creativity, with problem solving that happens below the level of conscious effort, with the integration of emotional experiences. When your mind wanders productively before sleep, it is doing real work. It is sorting through the events of the day, finding their place in the larger narrative of your life, releasing what doesn't need to be held, and preparing the ground for the consolidation that deep sleep will accomplish. Rain, by creating the acoustic conditions for restful mind wandering, is facilitating this process. It is not just helping you fall asleep faster. It is helping your brain do the work of resting well, the deeper kind of rest that leaves you genuinely refreshed, not merely unconscious. There is one more dimension to the default mode network and rain that is worth mentioning, and it leads us naturally into the next section. The DMN is closely linked with memory, particularly autobiographical memory, the memory of our own lives and experiences. And rain, as many of us know from personal experience, has a powerful ability to trigger memories, to carry us back, sometimes quite suddenly, to other rainy days, other times, other versions of ourselves. This is not coincidence. It is neurochemistry, and it is beautiful. Memory, nostalgia, and the rain of the past. There is a particular kind of memory that arrives on rainy days. Not a sharp, factual memory. Not a date or a name or a piece of information. More like a feeling or a texture. The sense of a particular afternoon from long ago. The smell of a specific room. The quality of light through a particular window. A feeling of childhood Saturdayness, or of a love story that began and ended, or of being small and safe and unconcerned with everything you're concerned with now. Rain does this. For many people, rain is one of the most reliable triggers for this kind of memory. Warm, sometimes bittersweet, always vivid in a way that is less visual than physical. You feel these memories more than you see them. And there is a reason for this that goes all the way down to the architecture of how the brain stores and retrieves experience. When you hear rain, the sound is processed in your auditory cortex, as we have established. But the auditory cortex is not an island. It is deeply connected to the limbic system, and particularly to two structures that are central to both memory and emotion: the hippocampus and the amygdala. The hippocampus is the brain's memory librarian. It is the structure that is responsible for forming new long-term memories and for indexing and retrieving stored ones. When you experience something emotionally significant, or something that occurs against a particular backdrop of sensation and feeling, the hippocampus encodes not just the event, but the context. The sounds that were present, the emotional state you were in, the ambient sensory quality of the moment. The amygdala works alongside the hippocampus as the emotional tagging system. It assigns emotional salience to memories. It essentially marks them with a note that says how emotionally significant this moment was. Memories tagged with high emotional salience by the amygdala are encoded more deeply and retrieved more readily than neutral memories. Now here is the thing about rainy days from childhood, or rainy days associated with significant moments in our lives. When those rainy days were encoded, when they were pressed into long-term memory by the hippocampus and tagged by the amygdala, they were encoded with rain as part of the context. Rain was part of the sensory package. The sound of rain is now, in your memory system, linked to those moments and their emotional qualities. Years later, decades later, sometimes when you hear rain again, the auditory cortex sends its signal to the hippocampus, and the hippocampus recognizes the contextual match. It doesn't just note, "There is rain." It begins to reactivate the neural patterns associated with all the previous times rain was part of a significant experience. This reactivation doesn't require effort. It doesn't require conscious direction. It happens automatically as the brain moves along its well-worn associative pathways. This is classical conditioning in the Pavlovian sense, except that instead of bells and dogs and food, we are talking about a complex, beautiful, deeply human system in which sounds and sensations and emotional states are woven together into an intricate web of association that persists, remarkably intact, for an entire lifetime. Researchers studying nostalgia, the bittersweet, often warm emotion of remembering the past, have found that it activates a specific network of brain regions. The hippocampus is central to this network, along with the ventral striatum, the brain's reward center, the medial prefrontal cortex, the posterior cingulate cortex, and the substantia nigra and ventral tegmental area, regions associated with dopamine release. When you experience nostalgia, your brain releases dopamine. Not the sharp, anticipatory dopamine of wanting something, but a gentler, warmer kind that is associated with the reward of meaning, of connection, of recognition. This is why nostalgia feels both sweet and slightly sad. The sadness comes from the distance. Those moments are past, and you cannot return to them. The sweetness comes from the dopamine and from the recognition that those moments were real and mattered. The net emotional experience is, for most people, net positive. A sense of warmth, of continuity, of being connected to a self that has persisted through time. Rain triggers this whole cascade. For many people, rain is one of their most potent nostalgic cues, precisely because it was present on so many of the quiet, interior childhood moments when they were most themselves. Reading under blankets, watching puddles form, listening to the drumming on the roof, feeling the particular cozy sufficiency of being inside while the weather happened outside. Those memories are associated with specific emotional qualities: safety, warmth, quiet, freedom from responsibility, the particular pleasure of having nowhere to be. And when rain triggers those memories, the emotional qualities come along for the ride. Your nervous system does not just remember that you were cozy during a rainy day when you were 8 years old. It partially re-experiences the coziness. It gets a dose of the dopamine that was associated with those warm, safe, uncomplicated hours. This is one of the reasons why rain sounds can feel, for many people, almost indescribably comforting. Not just physically calming in the way that pink noise and parasympathetic activation are calming, but emotionally comforting, wrapped around you like something familiar and loved, like the feeling of being known. And here is something remarkable. This conditioned response can be built and reinforced over time. If you regularly use rain sounds while doing something calming, relaxing, meditating, drifting towards sleep, you are adding new chapters to that associative story. You are deepening the link between the sound of rain and the experience of rest. Each time you settle into the rain sounds and allow yourself to become calm, you are making it incrementally easier to become calm the next time. The hippocampus is updating its model. The amygdala is retagging the rain sound with additional notes of safety and comfort. This is why sleep rituals work. Not just because they are habits, but because they are neurological conditioning. You are training your brain to associate a set of sensory cues, including sound, with the emotional and physiological state of winding down. Over time, the brain learns to initiate that state preemptively, before you even have to try. The rain starts. The brain says, "I know what comes next." And what comes next is rest. There is one more memory-related dimension to rain sounds that I want to touch on before we move on. There is a theory, and I want to be clear that this remains speculative, though it is grounded in developmental neuroscience, that rain sounds may connect to an even earlier memory than childhood. Pre-memory, in a sense. In the womb, the auditory system begins to function around the 23rd week of fetal development. For the remaining months before birth, the developing brain is immersed in sound. The mother's heartbeat, her voice, the sounds of her digestive system, and the ambient world filtered through abdominal tissue and amniotic fluid. High frequencies are attenuated by this acoustic filtering. Lower frequencies come through more clearly. The soundscape of the womb is continuous, rhythmic, low-pitched. A constant acoustic environment that the developing nervous system learns to recognize as baseline, as normal, as safe. Pink noise, which emphasizes lower frequencies and is continuous, has a frequency profile that overlaps meaningfully with the soundscape of the womb. Rain, which is approximately pink noise, shares this quality. The theory suggests that part of the deep resonance many people feel with rain sounds may be an echo, very faint, completely non-conscious, of the first acoustic environment any of us ever knew. We cannot know this for certain. The research on womb-to-postnatal acoustic continuity is real, and the rain as pink noise science is real, but the specific claim that rain reminds us of the womb requires a speculative bridge that science has not yet fully built. I share it as a possibility, not a certainty, but it is worth noticing how far back the roots of this comfort may go, how ancient and layered the response to this sound might be. ASMR and the tingling edge of sleep. At some point in the last 15 years, a word entered the cultural conversation that most neuroscientists had never heard before: ASMR. Autonomous Sensory Meridian Response. It's a mouthful, and it was coined not in a laboratory but in an online forum by a woman named Jennifer Allen in 2010, who was trying to find a way to describe something she and others had noticed themselves experiencing. a gentle tingling sensation that began in the scalp and spread down the back of the neck and sometimes the arms and spine, triggered by specific kinds of gentle, repetitive sounds and movements. Whispering, the quiet turning of book pages, tapping fingers on different surfaces, someone calmly explaining a process or procedure, the soft sounds of someone focused on a task. And consistently across thousands of reports, rain. What Alan and the early online community were describing was real. Researchers who have since investigated ASMR have confirmed its existence through multiple methods. People who experience ASMR show measurable physiological changes when exposed to ASMR triggers. Reduced heart rate, increased skin conductance, a marker of emotional arousal in its positive, engaged sense, distinct from stress, changes in brainwave activity, and in brain imaging studies, activation of specific brain regions including the nucleus accumbens, a core component of the brain's reward system, and areas associated with emotional processing and social bonding. A 2023 brain imaging study using fMRI found that ASMR sounds activated the nucleus accumbens specifically, which is a brain region associated with the experience of reward and positive reinforcement. The same region that lights up when you hear a piece of music you love, or when you receive social approval, or when you experience physical pleasure. This suggests that ASMR is not simply a relaxation response. It is, at least in part, a reward experience. Something genuinely pleasurable is happening in the brain, not just something that is merely not unpleasant. The estimated prevalence of ASMR sensitivity varies across studies, but some researchers suggest that perhaps 20% of people experience ASMR tingles, the distinctive physical sensation, in response to typical ASMR triggers. But more people report the relaxation and mood effects without the physical tingling. This distinction matters. You don't need to experience ASMR's characteristic tingling to benefit from the calming properties of gentle, repetitive sounds. The relaxation response appears to be more broadly distributed than the tingling. Rain is among the most commonly cited ASMR triggers across surveys and studies. The reasons align perfectly with what we know about why rain is calming more generally. It is gentle, it is repetitive but not mechanical. It is continuous, it is complex but locally predictable, and it carries no aggressive acoustic qualities. For ASMR experiencers, rain delivers a kind of auditory pleasure that is difficult to describe but instantly recognizable. A warming, softening quality that produces both the physical tingling and a corresponding emotional state of warmth and safety. But even for people who don't experience ASMR in the classic sense, rain sounds engage a related mechanism. Gentle, repetitive sounds that are associated with calm, focused, gentle attention, what ASMR researchers sometimes call personal attention sounds, activate a particular emotional quality that is close to what parents sometimes call co-regulation. When a trusted person is nearby, focused on a quiet task, the nervous system of a nearby person tends to regulate itself to match the calm of the other. This is a deeply social phenomenon. We are wired to take cues about emotional safety from the emotional states of those around us. ASMR sounds, including rain, seem to tap into this mechanism in an unusual way. They create the sensory impression of a safe, calm presence without requiring the physical presence of another person. This may be why ASMR became such a cultural phenomenon at exactly the moment in history when loneliness and social disconnection were rising. In a world that was becoming increasingly isolated, ASMR offered something that turned out to be deeply needed: the neurological impression of a safe, nearby presence, of being accompanied without being demanded of being close to something that meant you no harm. Rain in this reading is perhaps the original ASMR. Before whispering, before page-turning, before tapping, there was rain, falling softly, steady and safe, present in a way that demanded nothing. And when the brain receives this signal, this cascade of gentle, predictable acoustic input from a source it has long coded as non-threatening, potentially even from a source it recognizes from deep evolutionary and personal memory as associated with rest and safety, something very specific happens in the neural reward pathways. Dopamine is involved, but so too, researchers speculate, are oxytocin and endorphins. The combination of these neurochemicals produces a state that is difficult to describe precisely, but that most people recognize immediately: warm, held, a little sleepy around the edges, the world at a comfortable distance, neither too close nor too far. This is the edge of sleep. This is where the rain is taking you. Rain and sleep architecture. Going deeper. Sleep is not a single state. This is one of the most important and underappreciated facts about human rest. When you fall asleep, your brain does not simply go offline the way a computer might. Instead, it transitions through a sequence of distinct states, each characterized by a different pattern of neural activity, each serving different biological functions. Understanding these stages, and understanding how rain sounds interact with them, helps explain not just why rain helps you fall asleep, but why it helps you sleep better and wake up more rested. The first stage of sleep is what researchers call NREM1, non-rapid eye movement stage 1. This is the lightest stage, the threshold state, the place where most people feel themselves falling when they jerk awake with that sudden, physical startle. Brain activity is slowing from the alert beta waves of wakefulness into the slower alpha range, and then beginning to produce theta waves. Thought becomes fragmented. Images arise unbidden. You may feel yourself beginning to drift. This is also the stage where you are most easily woken. An unexpected sound, a car horn, a door, will pull you back to wakefulness from NREM1 without much difficulty. This is the stage where the acoustic masking effect of rain sounds is most important. By filling the acoustic environment with continuous, predictable sound, rain reduces the contrast of any sudden intrusive noise, making it less likely to pull you back to full wakefulness. It creates a kind of buffer zone, a soft, continuous backdrop against which individual sounds are less jarring. NREM2 is a somewhat deeper stage of sleep. Brain activity slows further, with theta waves dominant and the appearance of characteristic patterns called sleep spindles, brief bursts of high-frequency activity, and K-complexes, which are large, slow waves that may represent the brain's attempt to suppress responses to external stimuli. The body temperature drops. Heart rate and breathing slow further. This is where most of your night's sleep is spent. Roughly half of a typical night consists of NREM2. Research has found that pink noise can increase the density of sleep spindles during NREM2 sleep. Sleep spindles are associated with memory consolidation. They appear to be involved in the process of transferring information from short-term to long-term memory. More sleep spindles during NREM2 is associated with better memory performance the following day. If rain sounds, by virtue of their pink noise properties, promote sleep spindle activity, then they may be enhancing memory consolidation as well as relaxation. NREM3 is deep sleep, sometimes called slow wave sleep, because it is dominated by the large, slow delta waves we mentioned earlier. This is the most physiologically restorative stage of sleep. Human growth hormone is primarily released during deep sleep. The immune system is most active during deep sleep. The brain's glymphatic system, a recently discovered cleaning system that literally flushes waste products from the brain during sleep, is most active during deep sleep. Cellular repair happens at its highest rate during deep sleep. This is the sleep you can't fake. This is the sleep that leaves you feeling genuinely different in the morning, rested in a way that transcends simply having been horizontal for 8 hours. And here is the relevant finding. Steady, continuous pink noise like rain has been found in multiple studies to reduce the complexity and variability of brain wave activity during sleep, which promotes more stable entry into and maintenance of deep sleep stages. A 2012 study published in the Journal of Theoretical Biology found that steady pink noise significantly improved sleep stability and the percentage of time spent in deep sleep. Another study, focused on older adults who naturally spend less time in deep sleep, found that pink noise administered during sleep enhanced slow wave activity and improved next-day memory performance. The mechanism seems to be what researchers call entrainment, the tendency of oscillating systems to synchronize with an external rhythm when that rhythm is in a compatible frequency range. Pink noise, with its balanced distribution of frequencies including those in the delta range, may help to entrain or stabilize the brain's own slow oscillations during deep sleep, making it easier for the brain to sustain the slow wave activity that characterizes the most restorative stages. Beyond the direct effects on brainwave patterns, rain sounds may improve sleep quality through a second pathway, by reducing the microarousals that interrupt deep sleep. Microarousals are brief, partial awakenings, often lasting only a few seconds, that can pull a sleeper out of deep sleep and back into a lighter stage without the person being consciously aware of it. They are caused by intrusive sounds and other sensory disruptions. By masking these intrusive sounds, rain reduces the frequency of microarousals, allowing the natural sleep cycle to proceed with less interruption. This is why people who sleep with rain sounds often report that they feel more rested in the morning, not just that they fell asleep faster. The quantity of sleep may not have changed significantly, but the quality, the depth, the continuity, the proportion of time spent in deep, restorative stages may be meaningfully improved. There is also an effect on REM sleep, rapid eye movement sleep, the stage associated with dreaming. REM sleep plays its own crucial roles: emotional processing, creative problem solving, memory integration, and the maintenance of the neural connections associated with skills and learning. Research suggests that reduced stress and reduced cortisol levels, which rain sounds promote, as we have discussed, are associated with healthier REM sleep. When cortisol is chronically elevated, it disrupts REM sleep specifically, often reducing the time spent in this stage. By lowering cortisol, rain sounds may be indirectly protecting and enabling healthier REM sleep, with all the cognitive and emotional benefits that entails. So when you put on rain sounds tonight, you are not just giving yourself permission to relax. You are potentially improving the architecture of your entire night's sleep. The NREM stages, the deep sleep, the REM sleep, the smooth transitions between them. You are creating the conditions for your brain to do its overnight maintenance in a more complete and uninterrupted way. That is not a small thing. Sleep quality is one of the most important variables in long-term health, cognitive function, emotional regulation, and quality of life. And rain. The rain that has been falling since before there were creatures on Earth to notice it, the rain that has been soothing nervous systems since the first nervous systems existed, is quietly, steadily doing this work. Brainwave entrainment and the deeper science. Let's spend a little time with one of the most fascinating aspects of what happens to your brain while you listen to rain, because it opens up a dimension of the science that is both rigorous and genuinely strange in the best possible way. Your brain, as we have established, produces electrical oscillations. Neurons firing in coordinated patterns create waves that can be detected and measured by an electroencephalogram, or EEG, a device that picks up the tiny electrical signals produced by neural activity through electrodes placed on the scalp. These brainwaves are not metaphors. They are real, measurable electrical phenomena, and they correspond in consistent ways to different mental states and stages of sleep. What is remarkable, and what the field of auditory neuroscience has been investigating with increasing rigor, is that the brain's oscillations can be influenced by external rhythmic sounds. This phenomenon, called brainwave entrainment or auditory driving, refers to the tendency of the brain's oscillatory patterns to shift toward frequencies that are present in the acoustic environment. This is not a hypothetical. It has been demonstrated in multiple controlled studies. When participants are exposed to sounds at specific frequencies, including sounds embedded in broader noise environments, their brainwave patterns show measurable tendencies to shift toward those frequencies. The effect is not absolute or deterministic. It varies between individuals and depends on many factors, but it is reproducible and consistent enough to be taken seriously. Pink noise, with its particular distribution of frequencies that mirrors the brain's own natural oscillatory patterns, may be especially effective at this kind of gentle entrainment. The brain recognizes, at some level, an acoustic pattern that mirrors its own natural rhythms. And because neural systems tend to synchronize with compatible external rhythms when given the chance, this is a basic principle of coupled oscillators in physics and biology. The brain may lean into the pink noise pattern in a way that stabilizes and deepens its own natural oscillations. This could explain why pink noise promotes more stable slow-wave sleep. It could explain why alpha waves, associated with relaxed wakefulness and the dreamy state before sleep, are reliably increased by natural sounds, including rain. It could explain why rain has the distinctive quality of making you feel not just calm, but peacefully alert, suspended in a pleasant liminal zone where you are aware of your surroundings but not burdened by them. A 2018 study found that rainfall sounds specifically were associated with increased alpha wave activity in participants, the same wave pattern associated with deep relaxation and meditation. Alpha waves sit in that sweet spot between full alert wakefulness and sleep. They are the waves of a mind that has turned inward, that is not rushing toward any goal, that is content to simply be. This is the state that mindfulness teachers spend years teaching their students to cultivate deliberately. And rain, apparently, can get many people there without a teacher and without years of practice. The alpha wave finding is also significant because alpha waves are associated with reduced activation of the default mode network's anxious or ruminative patterns. When alpha waves are dominant, the mind tends to wander pleasantly rather than anxiously. The self-critical voice quiets. The replaying of embarrassing moments from years ago, which happens in that particular insomniac 2 a.m. way, tends to soften. The mental landscape becomes gentler. And as the alpha waves give way to the slower theta waves, which happens naturally as the brain slides toward sleep, the dreamlike quality of thought intensifies. Thoughts become more associative, more visual, less constrained by logic. This is the hypnagogic state, and it is one of the most mysterious and creative mental spaces the human brain occupies. Many artists, scientists, and writers have described their most intuitive insights arriving in this state. That peculiar waking dream zone at the edge of sleep. RAIN, by facilitating the brain's natural progression toward theta-dominant states, may also be facilitating this creative hypnagogic space. Not just rest, but a particular quality of rest that is also generative, that allows the sleeping mind to do its richest associative work. There is also, in all of this, a dimension that is simply worth sitting with for its own sake. The fact that your brain, right now, as you listen to or imagine rain, is literally changing. The oscillating electrical patterns produced by 3 pounds of tissue in your skull are being influenced, gently but measurably, by a sound. Not just recorded and noted, changed, shifted toward a slower, more spacious pattern that evolution and millions of years of neurobiology have associated with safety, rest, and the particular luxury of being alive without urgency. That is remarkable. That is, if you give it its full weight, one of the more astonishing facts about the nature of consciousness and the body it inhabits. That something as seemingly simple as water falling from a cloud can reach inside the deepest architecture of your mind and say, gently, it is okay to slow down now. The modern world and the ancient sound. Let's surface for a moment and look at where we are. You live in a world of extraordinary noise. Not just the kind of noise that has decibels and can damage hearing, though that kind of noise is more prevalent and more dangerous than most people realize. I mean noise in the broader sense. The unrelenting stream of information, stimulation, demand, and urgency that characterizes modern life. Notifications, news cycles, the ambient awareness that something is always happening somewhere, and that you probably should know about it. The blurring of work and home, of day and night. The way your phone sits on the bedside table like a small anxious companion, never fully asleep, always potentially available to pull you back from rest with something that has been engineered, quite deliberately, to activate your threat detection system and your reward system simultaneously. The human nervous system was not built for this. Your amygdala cannot tell the difference between a news alert about something genuinely catastrophic and a mildly stressful email from a colleague. It fires roughly the same cascade of stress hormones for both. Your threat-activated vigilance system, which was calibrated for a world where threats were physical and intermittent, is now exposed to a nearly continuous stream of symbolic and information-based triggers that keep it in a state of low-level chronic activation. This is the context in which the global popularity of rain sounds needs to be understood. The most played tracks on every major sleep and wellness app are, consistently, some variant of rain or running water. Tens of millions of people have discovered, often by accident, that putting rain sounds on at night makes them feel better, makes it easier to fall asleep, makes the morning feel more possible. This is not a trend. This is not a fad. This is an extremely large number of nervous systems spontaneously rediscovering a source of comfort that their brains have been able to recognize and respond to for the entirety of human history. The applications and devices we use to access these sounds are new. The sound itself is ancient, and the response to it, that particular softening, that lowering of the shoulders, that breath that releases before you even decide to take it, is older than any word we have for it. What does it mean, practically, to use this knowledge? It means that if you struggle with sleep, with the initial falling asleep, with waking in the night, with the quality of your rest, rain sounds are worth more than a casual experiment. They are worth a real, consistent trial. Sleep research consistently shows that behavioral interventions for sleep quality have very good evidence behind them, and acoustic environment is one of the most tractable variables in that domain. You don't need expensive equipment. You don't need a special room or a particular time. You need a rain sound, whether from an app, a recording, a white noise machine with a rain setting, or, if you're fortunate, an actual window with actual weather, and you need to let it run through the night. The research suggests that consistency matters. One of the ways classical conditioning works is through repetition. Each time you fall asleep with rain sounds, the association between rain sounds and the state of sleep becomes slightly more automatic. Over weeks and months, your brain learns to begin its wind-down process when the rain starts, before you've even had to try. The sound becomes a neurological shortcut to rest. It also means that if you find yourself anxious or stressed and you cannot sleep, and you decide to put on rain sounds, you are not engaging in wishful thinking. You are engaging in an evidence-based, neurologically coherent intervention that works through multiple simultaneous mechanisms: acoustic masking, parasympathetic activation, cortisol reduction, alpha wave promotion, default mode network modulation, and if you have been using rain sounds as a sleep cue for long enough, conditioned relaxation response. And there is something else beyond the functional benefits that is worth naming. The sound of rain connects you, in a way that is hard to articulate but very real to experience, to something larger than your immediate moment. To all the other humans who have heard this sound. To the long chain of nights and rests and rainy dawns that preceded you. To the fundamental fact that the world was making this sound long before there were beings with nervous systems to appreciate it, and will be making it long after. There is something grounding in that. Something that the anxious, forward-projecting mind, always worried about tomorrow, finds genuinely difficult to resist. The rain doesn't care about tomorrow. The rain is just rain. And in its not caring, in its pure, ancient non-urgency, it invites you to be just yourself. Just a warm animal in a shelter, listening to weather for as long as it takes you to fall asleep. That invitation, it turns out, is exactly what the nervous system needed to hear. Attention restoration and why we need the rain. There is a concept in environmental psychology called attention restoration theory. It was developed by Rachel and Stephen Kaplan in the late 1980s and early 1990s, and it has since accumulated a substantial body of supporting research. The core idea is this attention, the kind of directed, focused attention we use for work, for problem solving, for navigating the demands of modern life, is a limited resource. It depletes through use. And one of the most effective ways to restore it is through exposure to natural environments and natural sensory experiences. The Kaplans distinguished between two types of attention. Directed attention is the effortful kind, the kind you use when you're trying to concentrate on something you need to concentrate on. It requires active inhibition of distraction. It is genuinely tiring. It depletes. Involuntary attention is the effortless kind. The kind that is automatically captured and gently held by things that are interesting without being demanding. A fire, a flowing stream, clouds moving, a rain-streaked window. These things capture your attention without requiring you to direct it there. You don't have to try to be interested. The interest arrives naturally, gently, without cost. Involuntary attention, according to attention restoration theory, allows directed attention to rest and recover. When you are absorbed in watching rain fall, you are giving the directed attention system a genuine holiday. The executive networks of your prefrontal cortex, the ones that are tired from a day of decision-making and effort, can finally relax. This theory has been tested and supported in a variety of environments. People who spend time in natural environments recover from attentional fatigue faster than people who spend equivalent time in urban environments. People who listen to natural sounds, including rain, show improved performance on tasks requiring sustained attention after listening, compared to those who listen to silence or urban sounds. The auditory dimension is particularly interesting. Rain sounds provide exactly the kind of non-demanding, gently captivating sensory experience that attention restoration theory predicts will restore directed attentional capacity. They hold the mind lightly. They don't demand anything of the executive networks. They allow the tired, directed attention system to let go of its grip. This means that rain sounds are not just for falling asleep. They are useful at any moment when you are attentionally fatigued, which in modern life is much of the time. Many people have discovered that listening to rain while working reduces the sense of mental effort required for moderately complex tasks. The background sound reduces the fluctuations in attention, the little moments of distraction that constantly interrupt work, and it allows a state of mild, sustained engagement that is more productive and less depleting than the usual slightly scattered mode. A 2018 study confirmed that rainfall sounds as background noise during mental arithmetic tasks improved accuracy and performance. The researchers concluded that rain sounds elevate a state of relaxed arousal, a quality of calm alertness. That is, as it turns out, nearly optimal for many cognitive tasks. Not so stimulated that the mind is racing, not so relaxed that it is sluggish. That precise middle zone where attention can settle and work can actually happen. Attention restoration theory also connects to a broader truth about the relationship between human beings and the natural world. We evolved in nature. Our sensory systems were calibrated for nature. The ambient soundscapes of cities, traffic, machinery, HVAC systems, electronic noise, are, from the perspective of an evolved nervous system, deeply unnatural. They tax the system. They require constant, low-level processing to evaluate as non-threatening, because many of the acoustic signatures of urban environments partially overlap with threat signals. Nature sounds, including rain, do the opposite. They are the sounds the nervous system was built for. They are the sounds it can process effortlessly, the sounds it recognizes as belonging to an environment it understands. In a world full of the unnatural, rain is one of the most natural things most people will encounter in their daily lives. And the nervous system, every time it hears it, exhales with recognition. This is the deeper significance of the rain sound's healing power. It is not just chemistry or evolutionary signaling or acoustic masking, though it is all of those things. It is also simply homecoming. Your nervous system, battered and somewhat confused by the constant strangeness of the modern world, hears rain and recognizes it as something it knows how to be in, something it was built for, something that asks nothing of it, offers everything, and has been falling faithfully for as long as there has been water and sky. When the rain is playing and you are almost there, there comes a moment in the descent towards sleep that most people have noticed but few have been able to describe accurately. You are lying down. The rain is there, in the background, steady, unchanged. Your thoughts are still moving, but they're moving more slowly now, and they're less connected. One thought does not lead cleanly to the next. An image appears from somewhere unexpected. The train of logic has wandered off its tracks, gently, without anyone noticing. Your body feels heavier than it did 5 minutes ago. Not heavy in an uncomfortable way, heavy in the way that things feel when they are exactly where they should be. The blankets have become part of you, or you have become part of them. It is difficult to say which. The sound of the rain is still there. You notice it intermittently now, in the spaces between thoughts. It is doing what it has always done. Falling steadily, continuously, without urgency, without expectation. It fills the silence between your thoughts the way water fills a space, completely without effort. Something is letting go inside your chest. You cannot name it exactly. It is the thing that has been held all day, the vigilance that has not quite fully released until now. The thing that was always listening for the next demand. The part of you that has been half prepared for something to require your attention. That part is letting go. The rain helps. The rain has always helped. Not because it is magical, though there is something that feels close to magic in the effect, but because your brain knows what the rain means. Knows it in the oldest possible way, the way that doesn't need language or reasoning or intention. Knows it the way a body knows how to breathe. The rain means, this is a rest time. The rain means, you are inside. The rain means, the world will still be there when you wake up, and nothing that is going to happen tonight requires your continued vigilance to prevent. The rain means, you can sleep now. So you do. I want to leave you with something simple. The science we've covered tonight, the parasympathetic nervous system, the pink noise acoustics, the alpha waves and sleep spindles, the hippocampus and nostalgia, the ancient threat detection system and its ancient off switch, all of it is real. All of it has been studied by researchers working with EEGs and fMRI machines and cortisol assays and heart rate monitors, in laboratories where people wore electrodes and listened to sounds under carefully controlled conditions. And all of it, every last piece of it, is also just this. The sound of rain has been comforting human beings for as long as human beings have existed. Longer than civilization. Longer than language. In every culture, in every climate where rain has fallen, people have sought shelter and listened to it fall and let it carry them somewhere easier. We are fortunate enough to be able to explain now some of the mechanisms. We can name the chemicals and the brain regions and the evolutionary pressures. And that is genuinely valuable. Understanding why something works helps us use it better, helps us believe in it when we need to, helps us share it with people who need it. But the explanation doesn't diminish the experience. The sound of rain falling at night, when you are inside and warm and the world is at a comfortable distance, is still what it has always been. An ancient offer, a standing invitation, a sound that predates you and that will outlast you, that has no interest in your to-do list or your worries or the version of yourself you've been trying to maintain, and that asks of you only the simplest and most necessary thing, to rest. If it's raining where you are right now, open a window slightly, or put in your headphones, or simply notice the sound in the room. The rain we've been imagining together tonight. Let the sound be there. Let it stay. Let it do the ancient thing it knows how to do. You don't have to try. You don't have to understand it fully. You just have to let it. The rain is here. You are inside. You are safe. Sleep well. If this helped you understand your own relationship with rain a little more deeply, consider subscribing to Deep Science Sleep, where we explore the science of rest, consciousness, and the quiet wonders of the sleeping mind. Every video is designed for exactly the kind of night you're having right now. A little curious, a little tired, ready to rest but glad for the company on the way there. New episodes every week. See you in the next one.